Good afternoon, students. You are welcome back to the SFSF class. Last class we discussed salt, and I gave you the definition of salt and the types of salt. What is salt? This is what we discussed last class. Yes. Please clap for her. A salt is formed when the replaceable hydrogen ion of an acid is partially or completely replaced with a metal or ammonium ion. And what we did last was that we were able to classify the soluble salt and the insoluble salt. Just like I mentioned that all chlorides are soluble in water, with the exception of, what are those exceptions? Silver chloride, lead chloride, mercury chloride, and copper 1 chloride. Who does say copper? Copper 2 chloride is soluble in water. It is only copper 1 that is insoluble in water. Now we know the soluble salts, then we know the insoluble salt. Then how do we prepare soluble salt? Because preparation of salt depends on the solubility of the salt in water. Method of preparation of soluble salt is different from the method of preparation of insoluble salt. So let us look at preparation of soluble salt. How or what are the methods of preparing soluble salt? Number 1, by neutralization. By neutralization. That means we can prepare soluble salt by reaction between acid and base. We can prepare salt by reaction between acid, that is a reaction between, we have reaction between acid and base. For example, HCl reacting with sodium hydroxide will give us sodium chloride, which is salt, and water. This salt here is an example of a soluble salt. Sodium chloride is a soluble salt. Are we together? So that is one method of preparing a soluble salt, by a reaction between acid and base, which we refer to as a neutralization. 2. They can also prepare soluble salt by reaction between acid and triazocarbonate 4. Reaction between acid, reaction between acid and triazocarbonate 4 salt. So we have let's look at the example of between acid and triazocarbonate 4. To give example of hydrochloric acid reacting with potassium triazocarbonate 4. When acid reacts with, like HCl reacts with potassium triazocarbonate 4, the salt form is a soluble salt, potassium chloride. Alongside, we have carbon dioxide and water. What we have here is an example of a soluble salt. That's another method of preparing a soluble salt. Then we can also prepare insoluble salt by reaction between an acid and reactive metals. Reaction between acid, number 3. So we have reaction between dilute acid and reactive metal. For example, if zinc reacts with dilute hydrochloric acid, there will be formation of zinc chloride and there will be evolution of hydrogen gas. This zinc chloride produced is an example of insoluble salt. We have insoluble salt. That is another method of preparing insoluble salt. That means most times we want to prepare insoluble salt. We prepare between reaction between acid and either acid metal, thiocarbonate phosphate, or reaction between the acid and the base. The base could be insoluble salt, a soluble base, or insoluble base. What we use here is insoluble base. If you use soluble base, you are still going to have a soluble salt and water. Now let us go to the preparation of insoluble salt. Preparation of insoluble salt. How do we prepare insoluble salt? If a salt, when water is added to it, the salt did not dissolve, such salt is referred to as insoluble salt. Then how do we prepare insoluble salt? Number 1, we can prepare insoluble salt by double decomposition. By double decomposition, or you can call it by precipitation. I call it double decomposition or precipitation. That means it involves breaking down of 2 salts, and there is going to be exchange of radical between the 2 salts. We know we have said all chloride are soluble in water, with the exception of chloride of silver, lead, mercury, and copper. Now let's look at the reaction between lead nitrate, lead triazonitrate 5, and sodium chloride. When lead triazonitrate 5 reacts with sodium chloride, we call it double decomposition because each of the salts will decompose and there is going to be exchange of ion between the 2 salts. Now, when lead triazonitrate 5 breaks, you are going to have lead 2 ion and lead triazonitrate 5 ion. Then we have the sodium chloride will break into sodium ion and the chloride ion. Then what happens between the 2 salts? There will be exchange of radical. Then what will form is going to be lead chloride, and we have sodium triazonitrate 5. Now when you have double decomposition, 2 different salts will be produced. 1 soluble salt and 1 insoluble salt. But the method is specifically used to prepare insoluble salt. So now this is insoluble salt. So sodium triazonitrate 5 is insoluble salt, but the method is not specifically to produce insoluble salt. I hope you understand. So that means when you have double decomposition, 2 different salts will be produced. 1 soluble salt, then 1 insoluble salt. But the method is usually for preparing insoluble salt. The second method of preparing insoluble salt is by direct. We have direct combination of the constituent elements. Like iron 2 sulfide now is an insoluble salt. Most sulfide salts are insoluble. Sulfide salts are what? With the exception of the sulfide of sodium, potassium, and because we are saying all sorts of sodium, potassium, and ammonium are soluble. So if I want to prepare iron 2 sulfide now, I can combine the iron and sulfur. So reaction between iron and sulfur will give us iron 2 sulfide, which is an insoluble salt. As I want to prepare copper 2 sulfide now, I will combine copper and sulfur. So copper combined with sulfur will give us copper 2 sulfide, which is an insoluble salt. Basically, there are two methods of preparing insoluble salt. And what are these methods? Double decomposition, direct combination of the constituent elements. But when we talk of soluble salt, most textbooks, they will, instead of writing the reaction like this, they can break it into the reaction between acid and base and soluble base, the reaction between acid and insoluble base. In that case, we have gotten 2 points here. Apart from that, we can also get by reaction between acid and carbonate 4. Then reaction between dilute acid and active metal. So it is very important for you to write reactive metals because not all metal will react with acid to give us salt and hydrogen gas. Can anybody tell me the metal that will not react with dilute acid to liberate hydrogen? Copper. Yes? Copper, yes? Copper, mercury, silver, and gold. These metals, they are less reactive than hydrogen. Hence, they cannot displace hydrogen from acid. I hope you understand that. Now let us move on to the characteristics of salt. Let's look at the characteristics of salt. Salt can be classified into two: hydrous salt and anhydrous salt and hydrated salt. We have an hydrous salt. We have a hydrated salt. A salt without water chemically attached to it is referred to as anhydrous salt. But when water is attached to a salt, it is referred to as what? So you have this, given an example here. This salt is having water attached to it. This water that's attached to this salt is referred to as water of crystallization. It's referred to as what? Yes. The salt here without water of crystallization is referred to as, this salt has no water of crystallization attached to it. So it is referred to as an hydrous salt. Whereas the one that has water of crystallization attached to it is called hydrated salt. Now, efflorescent salt is referred to as a substance or a salt that when exposed to atmosphere loses part or all its water of crystallization. Please don't mix the two together. Efflorescence is the process whereby an hydrated salt on exposure to atmosphere loses part or all the water of crystallization. But the salt itself that loses water of crystallization on exposure to atmosphere is called efflorescent. Am I communicating? This is an efflorescent. Are we together? But when this, look at this, we have Na2CO3 with 10H2O giving us Na2CO3 dot H2O plus 9H2O here. This process is referred to as what? Efflorescence. But this salt itself is what? Efflorescent. So efflorescent is the salt which when exposed to atmosphere loses part or all its water of crystallization. But the process by which the salt or the exposure to atmosphere loses part or all its water of crystallization is called efflorescence. So if I ask to give example of efflorescent, so give example of sodium trioxocarbonate 4-decahydrate. I also have example of CuSO4.5H2O. That is copper 2 tetroxosulfate 6 pentahydrate. It's also example of what? Example of efflorescence, not sense. So that is what we do. Move on to, I hope you understand efflorescence and efflorescent now. You are not responding. Are you hungry? That's fine. So we have the liquescence and the liquescent. There are some salts that have affinity for water. Once they are exposed to atmosphere, they tend to absorb moisture large enough to turn them to solution. Such salts are referred to as the liquescent. But the process by which such salts absorb moisture large enough to turn into solution is called the liquescent. Please, when you are asked to define the liquescent, don't write the liquescent or don't define the liquescent. The salt, okay, the liquescent refers to as salt or substance which on exposure to atmosphere absorb moisture large enough to turn into solution. But the process by which a salt on exposure to atmosphere absorb moisture and turn to solution is referred to as the liquescent. I hope that is clearly understood. Can we give examples of such salts? H2SO4, sodium hydroxide. You see, okay. You see, you have to be very careful when the question is asked. We are referring to a salt. Is sodium hydroxide a salt? Sodium hydroxide is not a salt. But what? It's a base. Though it is a deliquescent substance. In brevity, that's what means that deliquescent, when you are talking of deliquescent, is not only peculiar to salt. Are we together? Sodium hydroxide is deliquescent, but it is not a salt. In fact, most students, when they are asked questions in the exam, they make such mistake. And it's zero. No, at times when you are asked to give an example of deliquescent salt, you just come out with jubilating yes. Mentioning potassium hydroxide, sodium hydroxide. These two are the liquid substances, but they are not salt. So it will be wrong for you to write them as an example of the liquid salt. But if the question says, give example of the liquid substances. A substance could be an acid, it could be a base, it could be an acid, it could be anything. But when it is specified, give example of the liquid salt. If you write potassium hydroxide, you write sodium hydroxide, it is what? Even though they are the liquid, but they are not. So you cannot give potassium hydroxide and sodium hydroxide as an example of the liquid salt. So we are dealing with characteristics of salt. We will not place this one there. Please get my point clearly. They are the liquid. They are not classified because they are what? They are not salt. They are bases. Is that taken? Now let's give an example now. What are the examples? You only are aware of sodium hydroxide and potassium hydroxide because they are common in the laboratory. You see them. If you are given the gradient, you see no time turns to absorbing motion and return to solution. They are the liquid salt, but they are not salt. Don't treat them as an example of the liquid salt. So we have calcium chloride. We have zinc chloride. We have magnesium chloride. Most chloride salts are the liquid salt, but the rate at which they absorb moisture differs. Iron 3 chloride is also an example of the liquid salt. Even at times when you have sodium chloride keep for so many times, you begin to absorb moisture. But it is not all that as the liquid as others. They may not turn to solution. When you go to our lab, most of calcium chloride we have now, our lab has turned to solution. Because as you begin to take little quantity of salt from it to be exposed to atmosphere, so that means we are absorbing moisture. So get to the time that instead of you having it in powder form, just what to solution. Because it is what? The liquid salt. After grammar school, you have salt, you have many of those salts in the laboratory there. Calcium, especially the calcium chloride and the zinc chloride. You have a lot of zinc chloride there. Has turned to solution. Someone now asks you, is this one a solution or a salt? Because it is what? Now, let's go to the next one. Hygroscopy and hygroscopy. So hygroscopy and hygroscopy. The substance that absorb moisture but not large enough to turn into solution is referred to as hygroscopic substance. Moisture but not large enough to turn into solution is called hygroscopy. You know, both hygroscopic and the liquid substance, they have tendency to absorb moisture. But what's the difference between the two? When the salts absorb moisture and turn to solution, it is what? The liquid. But when it only absorbs moisture and becomes sticky, the substance is hygroscopic. Now, what are the examples of hygroscopic substances? Example of hygroscopic substances. Yes? H2SO4. So, we have example of concentrated H2SO4. Yes? Silica gel. Yes, let's give an example of silica gel. Yes. Potash. Calcium oxide. Yes. Calcium oxide. Yes. We have sodium triazonitrate 5. Because of all what you have listed, it's only one here that is a salt. But others, they are always what? They are hygroscopic. The point I'm leaving the emphasis here is this. When you are asked to give a sample of salt, don't write anything except salt. Is that it? But when the question say substance, write anything that anything that is related to what? 10% or hygroscopic. So that you don't see the right and give example of 10% substance. Now see if you want of anything, you begin to give example of silver chloride or barium triazocarbon. So don't. Now let's go to any question on this before we move on. Any question on this? Feel free to ask question. There is no question, I will ask question. Yes? Okay, at the end of the day, I will ask you a question. Now let's go to hydrolysis of salt. Or hydrolysis. 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 What do you mean by hydrolysis? Hydrolysis means reaction between salt and water. So hydrolysis of salt. Hydrolysis of salt. That is reaction between salt and water. When salt reacts with water, the resulting solution will be an acid, base, or neutral. And that depends on the strength of the acid and base from which the salt is formed from. When you react base and water together, the resulting solution could be what? Basic, or it could be what? Acidic, or it could be neutral. The strength of the acid and base from where the salt from determines if the salt is going to be acid, base, or neutral. For example, let us look at reaction hydrolysis of sodium triazocarbonate 4. We have hydrolysis of sodium triazocarbonate 4. When you say hydrolysis of sodium triazocarbonate 4, we are referring to reaction between sodium triazocarbonate 4 and water. So that means we have Na2CO3 reacting with H2O. During hydrolysis, you expect each of these substances to break, just like I've explained in double decomposition. And there's going to be exchange of the ion to give the resulting acid and base. So this will give us Na2 plus CO3 2 minus and water into hydrogen ion and the hydroxyl ion. Then we have the Na2OH, then this to this. Then what do we have now? We are going to have NaOH and H2CO3. That means when you dissolve Na2CO3 in water, the reaction will occur between the water and the salt. And what you have in the solution is going to be sodium hydroxide and H2CO3. Now, what type of base is sodium hydroxide? Strong base. And what type of acid is H2CO3? This is weak acid. You know the strength of base will override that of the acid. That means the solution is going to be what? Basic. And that is why during acid-base titration, if you are given the solution of sodium trisulcarbonate 4, it serves as what? Solution of sodium trisulcarbonate will serve as what? To serve as a base. Because the solution of Na2CO3 in water was going to give a strong base and a weak acid. And because this base A is strong and the acid is weak, the solution becomes what? The solution becomes what? Basic. If you test the solution with litmus paper, what happens? The effect of the base is going to be felt, not H2CO3. And in that case, the solution will turn red litmus paper. Ordinarily, when you talk of a salt, it's not supposed to be a neutral solution, and it's just neutral substance. But when it's added to water, there will be a reaction between the salt and water. And what is given us is that strong base. It is that strong base that is keep turning the litmus paper from red to blue. So let us look at another example. Let's look at another example. So let us look at hydrolysis of ammonium chloride. That is the reaction between ammonium chloride and water. So let's also look at what happens when ammonium chloride dissolves or reacts with water. You can tell me the product of this, just like I did for Na2CO3 and H2O. Use this example now to tell me the product of reaction between ammonium chloride and the water. Yes? Ammonium hydroxide, and so we have NH4OH plus HCl. Now, what type of base is ammonium hydroxide? This is weak base. And this is what? Strong acid. Because the acid is strong and the base is weak, so the effect of the solution is going to be what? Acidic. And it means the solution of ammonium chloride is going to be what? Acidic to litmus. How does that mean? The solution will turn blue litmus paper. All these are hydrolysis of salt. If you understand it perfectly, it will help you when we get to the salt analysis. Thank God this Saturday you are going to have practical. I'm going to have practical this Saturday, and one of the things you are going to do is a salt analysis. If you are given a salt, you may be asked to test the solution of the salt with litmus. The whole essence is to know maybe the salt given to you, its hydrolysis in water will be acidic, neutral, or basic. So it means when you are given a salt, you are asked to add water to it and test with litmus. You can confidently say that the salt given to you is either an acidic salt. No, it's either the solution is either acidic, neutral, or basic. Please don't mix the two together. No. If I ask you what type of salt is that somebody asked that question in last class. If I write NaHCO3 and I write NH4Cl, what type of salt is this? Is what? What type of salt is this? What type of salt is this? It is what? Why are we now saying this salt now is acidic in solution? It means the salt has reacted with what? With water. There is reaction between the salt and water to give us what? This and this. It is the HCl that is present when dissolved in water that make the solution of the salt to be what? Acidic. Is that taken? So let's look at another example. Hydrolysis of potassium chloride. Hydrolysis of potassium chloride. That is the reaction between potassium chloride and what? So let's look at what happened. We have potassium chloride reacting with water. What will be formed, or what are the products? KOH and what? HCl. Potassium hydroxide is an example of a strong base. HCl is an example of a strong acid. Since the acid is strong and the base is also strong, the effect will cancel another and the solution becomes what? So it means when you add potassium chloride to water and you test with litmus, the litmus paper will not have effect, or the solution will not have effect on the litmus paper. Is that okay? Now you know what happens when a salt reacts with the solution could either be that is good. Now let me give you small class exercises there. Class. State what you would observe if it was paper. State what you observe if litmus paper is dipped separately into the solutions of the following salt: aluminum chloride, potassium trisulcarbonate 4, copper 2 tetrasulfate 6, potassium tetrasulfate 6, then potassium trisulnitrate 5. Let me add one more to it. Verse 6, we have NaOH. sodium chloride, not sodium chloride, not sodium hydroxide, sodium chloride, not sodium hydroxide. In the solution, what happened to the solution of this salt when you add litmus paper to it? One blue to red. Let's look at it. Let me write it there. Blue to red. What happened to the litmus paper when you dip inside solution of K2? Red to blue. We are going to look at it together, red to blue. Then the solution of CSO4. What happened to it when you blue to red, blue to red? What happened to the solution of K2SO4 when you dip neutral, no effect on litmus? What happened to the solution? Also neutral, no effect. Then what happened to the sodium chloride? No effect. These are your responses. So let us check if your responses are correct. So let us find the hydrolysis of each of the salt and let's look at which of the strengths predominates. So maybe the solution is when aluminum chloride reacts with water, then we are going to have aluminum hydroxide and what? HCl. Is this equation balanced? 3 here. Now let us look at the resulting strength of the acid and base when aluminum chloride reacts with water. This is a base, a weak or strong? Weak base. And this is what? Strong acid. Because the acid is strong, it means when you put litmus paper into the solution, litmus paper will turn from blue to red. That means your answer here is right. So it means the solution of aluminum chloride is acidic and it will turn blue litmus paper red. Number 2, we have hydrolysis, that is when you have C2, K2CO3 reacting with water. What will be the product of this hydrolysis? We have KOH plus H2CO3. This is a strong base. This is a weak acid. Because the base is strong and the acid is weak. When you put litmus paper here, which is red, it will turn to blue. So it's also right. The solution of K2CO3 turns red litmus paper blue. Move on to the next one. Let's look at the hydrolysis of copper 2 tetrasulfate 6. Now when copper tetrasulfate reacts with water, what will be the product? Copper hydroxide plus what? H2SO4. What type of base is copper hydroxide. So we have a weak base, then we have a strong acid. Then the solution of the salt will turn blue litmus paper red. This is also right. Then we'll move on to the next one. Hydrolysis of potassium tetraoxosulfate. This will give us potassium hydroxide and what? H2SO4. What type of base is this? This is a strong base, and this is what? A strong acid. Both acid and base are strong. Then what happens to the solution? It's going to be a neutral solution. Then it will have no effect on litmus. Then we have KNO3 react with water to give us what? KOH plus what? HNO3. This is a strong base. This is a strong acid. Then the solution becomes neutral, and it's going to have no effect on litmus paper. And finally, the hydrolysis of sodium chloride in water will give us sodium hydroxide and HCl. Sodium hydroxide is a strong base. HCl is a strong acid. Again, both acid and base are strong. The solution of the solution of the salt is neutral, so it has no effect on the litmus. I hope I now do know which salt will be basic in solution, which one will be neutral in solution, and which one will be acidic in solution. I know the reason. How many of you do not get all the 6 questions? Now you know the correction to it. So we'll move on to water of crystallization. Water of crystallization. So let's really look at that. Water of crystallization. Just like I explained the other time that when salt has water of crystallization attached to it, the salt is referred to as hydrated salt. But the salt without water of crystallization is referred to as. Now, what is this water of crystallization? It is the fixed or definite amount of water. Is the fixed or definite amount of water that is chemically combined. Is the fixed or definite amount of water that is chemically combined to a salt in its crystalline form. It is fixed or definite amount of water that's chemically combined to a salt in crystalline form. That means when we talk of water crystallization, it's usually in whole number. You cannot have 4.5 H2O attached to a salt. It is usually what? Whole number. Now, we'll do little arithmetic here. How we can determine the number of molecules of water of crystallization attached to hydrated salt. So in doing so, how do we determine that? We can use this, any of these formulas to find that. We can find mass of water of crystallization over mass of anhydrous salt is equal to molar mass of water of crystallization over molar mass of anhydrous salt. Or we can use mass of water of crystallization over mass of hydrated salt is equal to molar mass of water of crystallization over molar mass of hydrated salt. Or we can use the mass of anhydrous salt over mass of hydrated salt is equal to molar mass of anhydrous salt over molar mass of hydrated salt. You can use any one of these formulae to determine the number of molecules of water of crystallization that is attached to the hydrated salt. All you need to know is to know the molar mass and the mass of the hydrated salt. You know what we call hydrated salt is a salt that has water of crystallization, and the hydrated salt is going to be that salt without water of crystallization. Of course, you know the mass of hydrated salt is going to be more than the mass of anhydrous salt. If the mass of hydrated salt is usually more than the mass of anhydrous salt, because most time when the salt loses mass or all its water of crystallization, there is going to be decreasing. So we are going to look at the example. Let's look at calculation there. .0 gram of a barium sorry 5.0 gram of hydrated 5.0 gram of hydrated salt of barium 5.0 gram of hydrated salt of barium when heated to a constant mass. When heated to a constant mass, gave 4.26 gram. Give 4.26 gram of anhydrous salt. Give 4.26 gram of anhydrous salt with a molar mass of 208 gram per mole. With a molar mass of 208 gram per mole. What is the number of molecules of water of crystallization? What is the number of molecules of water of crystallization in the hydrated salt? Now, read the question and digest it, and tell me which of the formulae written on the board is appropriate for that calculation. Let me know by 1, 2, 3. Which of the formulae on the board is appropriate for this calculation? Number 1, number 3, number 4. Number 1 is appropriate. Look at it very well. Read the question. Have you read the question? Do you even understand the question at all? Number 3 is appropriate. Number 3 is appropriate. Number 2 is appropriate. That means you are telling all the 3 appropriate. Number 1. You can use any of them. Yes, now. You can use anyone to get the answer. Now use number 1. You can as well use 2 and 3. Now if you go by number 1, number 1 says mass of water of crystallization. We assume that that salt is something like this, BaX.YH2O. This is the salt, which is an hydrous salt, and this is the water of crystallization that is attached to it. Barium is this. It must have an anion. I have presented that X as the anion attached to it to make it a salt. Y represents the number of molecule of water of crystallization. Remember, the whole of this one is given, the molar mass is what? 208. So if I use this one now, the mass of water of crystallization is going to be what? Are we given that question? But you can find it. The mass of water of crystallization is going to be mass of hydrated salt minus mass of anhydrous salt. So that is going to give us what? That is 5 minus 4.26. Are we together? Some are not talking now. That will be mass of hydrated salt minus mass of anhydrous. What is mass of hydrated salt? 5. What is mass of anhydrous salt? 4.26 divided by the mass of anhydrous salt is 4.26 is equal to, what will be the molar mass of water of crystallization? Yes? 18Y or 18S, depends on what's given. You know, there must be, because that molecule is what we want to determine, it will contain water. But the number of molecules that's attached to it, you don't know it. We use Y. So it goes to what? 18Y. And if you use S, it's not out of it. Just use an alphabet to represent that number you are looking for. Divided by, what is molar mass of anhydrous salt? It is given in the question to be what? 208. Then what is 5 minus 4.26? What? 0.74 over 4.26 is equal to 18y over 208. Subject of the formula, you have y is equal to 0.74 times 208 divided by 4.26 times 18. So what value do you get here? 2. So y is equal to 2. It means the number of molecules of water of crystallization attached to that salt is 2. Remember, your answer must always be to whole number. That's why I said water of crystallization is the definite or fixed amount of water that is chemically combined. So let's look at one example. Now we have 0.499 grams. 0.499 grams of CuSO4 dot X H2O. CuSO4 dot X H2O. When heated to a constant mass, left a residue of 0.346 grams. What is the value of X? What is the value of X in the hydrated salt? I repeat the question. 0.499 grams of CuSO4 dot X H2O when heated to a constant mass left a residue of 0.346 grams. What is the value of X in the hydrated salt? Write in brackets. C is equal to 63.5. S is equal to 32. O is equal to 16, then H is equal to 1. Now, just like we did for the first calculation, we can as well use this formula here to determine the value of S. The value of S you have to find here is the number of molecules of water of crystallization. So let us use this first formula, or you want us to use another formula. So the first formula is the simplest one, so let us do that. So mass of water of crystallization there is going to be the mass of hydrated salt minus, that residue is going to be the mass of anhydrous salt. And that's going to be 0.499 minus 0.346 over 0.346 is equal to, that is going to be 18x over, then we are going to calculate the molar mass of CuSO4. That is 63.5 plus 32 plus 64. I hope you remember we are closing this 64. 16 times 4. What is 0.499 minus 0.346? 0.153 over 0.346 is equal to 18x over, what is the value of this? 159.5. Then make x the subject of the formula. Okay, let's just say 0.346 times 18x is equal to 0.153 times 159.5. Then x is equal to 0.153 times 159.5 over 0.346 times 18. Then x is equal to yes, 8.92, 53, 3 points. Is that going to be the answer? I've told you the number is what you have is definite. So the answer is what? 4. .4 gram of hydrated barium salt on heating gave 2.13 gram of anhydrous salt. 2.4 gram of hydrated barium salt on heating gave 2.13 gram of anhydrous salt. If the molar mass of anhydrous salt is 208, if the molar mass of anhydrous salt is 208, determine the number of molecules of water of crystallization. Determine the number of molecules of water of crystallization. Number 2. 4.3 gram of hydrated 4.3 gram of hydrated sodium tetraoxosulfate 6. 4.3 gram of hydrated sodium tetraoxosulfate 6 was heated to remove water of crystallization. Was heated to remove water of crystallization. The remaining anhydrous salt had a mass of 2.12 gram. Calculate the number of molecules of water of crystallization. Calculate the number of molecules of water of crystallization in the hydrated salt. Calculate the number of molecules of water of crystallization in the hydrated salt. You have Na is equal to 23. Na is equal to 23. S is equal to 32. O is equal to 16. Then H is equal to 1. Solve that. The mass of water of crystallization. How do you find the mass of water of crystallization? Yeah, what is mass of binding salt? 2.4. 2.4 minus what is mass of 2.13 over 2.13 is equal to, that is 18x over 208. Then we can now cross multiply. You have 2.13 times 18x equals, what is 4.2 and 2.4 minus 2.13? 0.27 times 208. Then s equal to 0.27 times 208 divided by 2.13 times 18. Then the answer will be what? 1. Who said 2? 1 point. 1.4 should be what? Should be 1. 1.4 will be 2. 1.46. How will 1.46 now become 2? Are you going to approximate twice? Because of approximate 4 to 5, then 5 to 1. Go ahead and improve your mathematics. Now, question 2. Question 2. What did you get? 8. 9. 8, 9. 7, 8, 9. It's okay. Let us be together. Then you say maybe you get it right or you miss it. There is no problem. Now we use 4.3 minus 2.12 over 2.12 is equal to, this is 18x over, now we need to calculate the molar mass of the anhydrous salt. Anhydrous salt is Na2SO4. This should be 46 plus 32 plus 64. Is that? Then we have, what is 4.3 minus 2.12? 2.18 over 2.12 is equal to 18x over, what is all of this? 142. Then from here we can say 18x times 2.12 is equal to 2.18 times 142. Then s is equal to 2.18 times 142 over 18 times 2.12. So if you press your calculator, what do you get for this? 8. Those of you that arrive at 7, where do you get it? And those that got 9, what happens to your answer? That you have 7 and you have 9. So the correct answer there is 8. So I believe if you are given or you're asking any question on salt, be it a soluble salt, the preparation of soluble salt, preparation of insoluble salt, and if you are given a salt, you hydrolyze the salt in water, you should know what the result of that salt will give you. Will it pH less than 7, equal to 7, or greater than 7? Or will the salt solution turn blue litmus paper to red, or red to blue, or have no effect on the nature? So until we meet again tomorrow for another chemistry class, do enjoy yourself. Good evening.